Hello students, welcome to this online course of hydraulic engineering. So in the previous lecture we have learned the concept of dimensional homogeneity. So today we will use that concept and we will try to solve some problems, and also we will learn the concept of Rayleigh's theorem, how we are going to use for our dimensional analysis. So let us try to solve this problem. So the problem states that the Manning's formula for velocity of flow in uniform flow in an open channel is written as, this is the formula given: v is the velocity and it is equal to 1 by n r raised to power 2 by 3 s raised to power 1 by 2, where r is the hydraulic radius and s is bed slope and n is the Manning's coefficient. So we have to determine the dimensions of the this Manning's coefficient. So generally the coefficients are dimensionless, but in this case let us try to solve for n whether it is coming out to be dimensionless or not. So what would be our approach, how we are going to solve this? So this you have done in your previous classes. So what we should do, we are having velocity is equal to 1 by n and something is something like this. So what we will be doing, by dimensional homogeneity, what we can say, v minus 1 by n r raised to power 2 by 3 s raised to power 1 by 2 will be 0. So these two terms are additive in nature. That means both the quantities should have the same dimensions. Clear? So that means left hand side, dimension of left hand side is what? Meter per second. 1 by n, leave it as it is. R is what? R is radius. Radius means meter raised to power 2 by 3, and s is slope. Slope is having no dimensions. Okay, so it is having no dimension, it is dimensionless quantity. So n will be what? M raised to power minus 1 by 3 s minus 1. So this is the dimensions of your what? N. So I have solved this problem, also you can check. So n is, the dimension of n is coming out to be L raised to power minus 1 by 3 t, because t here is in minus 1, so in the numerator it will become plus 1. So this is the dimension of n. Clear? So let us try to understand Rayleigh's method for dimensional analysis. So like this, the method which we have used for the calculation of n is also a part of Rayleigh's method. So why we are going to use this? Because it gives a special form of relationship among the dimensionless groups. What are the dimensionless groups? That we will be seeing later on. And in this method, what is the inherent drawback? It is that it does not provide any information regarding the number of dimensionless group to be obtained as a result of dimensional analysis. So it is giving the relationship between different dimensionless groups, but the major drawback is what? We are not sure how much dimensional functions or how much dimensional number of groups we have to form. So this problem was solved by Buckingham and in his pi theorem, so that we will see later. But right now we are trying to understand Rayleigh's method, and this method is used for determining the expression for variables which depend upon maximum of 3 or 4 variables only. So this is one more drawback. If you are having number of variables more than 3 or 4, like it is 5, 6, 7, 8, then this method is very cumbersome. So this is calculations will become very, very complex. So in those cases, what we will be doing, we will be using the Buckingham pi theorem. So first we will try to solve few problems, and we will try to understand what type of problems if we are using Rayleigh's method, what type of problems we will be facing. So before attempting the problem, try to understand the steps involved. So what is the first step? If a is a variable, let us say a is some variable which is depending upon various variables, a1, a2, let's say till an, and these are independent variables. Okay, so a, what we will be doing, we can write a as k times a1 raised to power a a2 raised to power b, like that. Now again what we will be doing, we will write the dimensions of a here, and we will write the dimensions of a1, a2, a3, all the parameters, and we will compare the power of m, l, t on both side, and by comparing we will getting the values. Okay, so after that we will get the dimensionless group which are controlling the phenomena which we are going to deal now. So what is the last point? While this method is simple for small number of parameters, it becomes rather cumbersome when a large number of parameters are involved. As I have told you, if the parameters are high, like 6, 7, 8 parameters, some physical quantity is there, like it is depending upon the 7, 8, like let's say 10 parameters, then if you are going for release method, it will be, your life is not going to be simple. So for those cases, this drawback was seen by Buckingham, and he introduced his new theorem, where you will be easily solving like any number of variables you can easily solve for that. So before going to Buckingham pi theorem, let us try to solve some problems with the help of release method. Okay, so what is the release method? Like what is, how we are going to deal with? So this is the first question. The drag force Ft on a sphere in laminar flow is known to depend upon its diameter, which is capital D, velocity of flow, which is capital V, density of fluid, which is rho. Okay, d rho, and coefficient mu, this is coefficient of viscosity mu. Obtain expression of Fd using release method. So what it is saying, Fd is depending upon d, v, rho and mu. Okay, so this type of relationship we have given in the question. Now what we will be doing, we will write the dimensions of F here and all the dimensions of like d, v, rho and mu, and after that like this is m, l, t minus 2 here. So the coefficient of m this side will be compared as 1, coefficient of l will be equal to 1, and coefficient of t will be equal to minus 2. After that we will get a, b, c, d, and we will put the values, and we will see how like this is varying with like various parameters like d, mu, rho and v. Clear? So let us try to solve this problem. So Fd is a function of d, v, rho and mu. So as I have told you, Fd we will write d k times, k is a dimensionless constant. So d raised to power a, v raised to power b, rho power c, and mu power d. So what we have done, we have written the dimensions of d will be what, d is diameter, so length, velocity is lt minus 1 meter per second, like rho is what, density is kg per meter cube, so ml minus 3, and mu is ml minus 1 t minus 1. So we will club the coefficient of m, l and t in this equation, you can see. So here you can see m raised to power c plus d, so c plus d will be equal to 1, you can see here. A plus b minus 3c and minus d will be equal to 1, again here you can see, and minus b minus d is equal to minus 2. So these three equations we are having, and we are having 4 number of unknowns, so this is not possible to solve. So what we will be doing, we will be choosing one of the dependent parameter, and we will try to express other 3. Like if you are taking c, let us say we are taking d as a, like we will independent parameter, and a, b, c will be depending upon d. So this means we will be expressing all the other 3 parameters like a, b and c in terms of d. So from first equation you can see c is equal to 1 minus d, 1 is equal to c plus d, so c is what, 1 minus d. Same by using this formula, like from here you will get b is 2 minus d, here you can see 2 minus d, sorry here it is b is equal to 2 minus d, and again after solving this equation, after putting all the values, you will find a is also 2 minus d. Clear? So a and what, c, a and b are having same dimensions, power. So now what we have to do, we have to put all the values in this equation. So here you will be putting all the values. F is equal to k raised to power 2 minus d raised to power 2 minus d, v raised to power 2 minus d, rho raised to power 1 minus d, and mu raised to power d. Now we will be clubbing all the power which are having d, and other powers we are knowing just d square by d. D raised to power 2 minus d can be written as d square by d. V raised to power 2 minus d can be written as v square by v square upon v raised to power d, and rho by rho upon rho raised to power d, and mu raised to power d. So this equation you can see. So now what we are doing, we will be clubbing the powers which are having now we will be clubbing the parameters which are having power d. So here you can see this final term we are getting. That means if you are going to calculate the dimension of this quantity mu upon v, rho and d, you will be seeing that this is a dimensionless quantity. So the dimensionless group which we were talking about this thing. So that is okay, it is coming to be a dimensionless number. But what is the problem here? We do not have any idea how much dimensionless group we are going to form during the analysis part. So finally we can write this like the variation of FDS rho d square v square and some function of this dimensionless group. If you will check the dimension of rho d square v square, you will find that it is having the dimension same as of force. Clear? So this was our first problem. In this problem only 4 unknowns were there. Now let us try to solve one more problem, which is the drag force F on a body in supersonic flow is considered to depend on the length capital L, velocity v, diameter d, the fluid properties like density rho, dynamic viscosity mu, and bulk modulus E. Derive an expression for F. So now here you can see how many unknowns parameters 1, 2, L, d, v, rho, mu, and E. B, C, D, E, F. K times this is equal to F. Now you can see your life is going to be hell if you are having 6 number of equations, 6 number of parameters, and only 3 equations are there. How we are going to deal with that? Let us see. Again same problem. What we have to do? We have to write the dimensions of quantities both the sides, and after that we have to equate the powers of M, L, and T. Here also 3 unknowns are there and 3 equations, 6 unknowns and 3 equations. So what we are going to do, we will be expressing A, B, and D in terms of C, E, and F. Okay, so these are independent parameters we are assuming, and these are dependent parameters. So after solving all the quantities, you will be getting A, D is 1 minus E minus F, B is 2 minus E minus 2F, and A is 2 minus C minus E. So you can see only unknowns are in terms of C, E, and F. Okay, put the values, and here you will be getting something like this. Here you can see like 1, 2, and 3 number of dimensionless groups are there. So if you will check the parameters here, d by L will be meter by meter, that is dimensionless. Mu upon rho LV, this is a very important number which we will be going to see in Buckingham pi, like in the model analysis. And E by rho V square is also a very important dimensionless number which we will be seeing later on. So finally this is our answer. This is how the variation look like. So rho V square L square, some function of d by L, mu by rho VL, and E by rho V square. So this is how we are going to deal with our Rayleigh's method problems. So in the next lecture we will be seeing how like Buckingham has made our life very simple by introducing its theorem of pi theorem. So that we are going to see in the next lecture. So this is all for today. Thank you.